Alright guys, we're going to be working practice problems from our book. This is over light and the electromagnetic spectrum. We're going to start on page 119 with number 31. Now the question says determine the frequency of light with a wavelength of 4.257 times 10 to the 7th centimeters. Now the first thing we have to do is write down what the problem gives us. First of all, it gives us the wavelength of light, which is 4.257 times 10 to the negative 7th, and the unit for that is centimeters. Now, it wants us to find the frequency. So frequency is going to be our unknown. Okay, another thing that we have is we know the speed of light. We know that c equals 3.0 times 10 to the 8th meters per second. Okay, the equation that we're going to be using is the c equals wavelength times frequency. Now, what we'll go ahead and do here, since we know we're solving for frequency, we have to get frequency by itself. So to do that, algebraically, all we do is divide by the wavelength, and we will get frequency equals the speed of light divided by the wavelength. Okay, so now we have our unknown, we have our given, we have our equation, we sorted it out. Let's go ahead and solve it, and we'll have our frequency, which will equal 3.0 times 10 to the 8th meters per second, all divided by the wavelength. And the thing here with the wavelength, what we have to realize is that it's in centimeters, okay? And the speed of light is in meters, okay? So before we can plug it in, we have to change this into meters as well, because centimeters and meters would like be comparing apples and oranges. It just doesn't work. So to change that into meters, all we do is we do a little conversion. We have 4.257 times 10 to the negative 7th centimeters. And we know that 100 centimeters equals 1 meter. So that's going to give us a wavelength of 4.257 times 10 to the 9th meters. We go ahead and plug that into the equation. We have 4.257 times 10 to the negative 9th meters. And what this is going to give us is going to give us frequency of 7.047 times 10 to the 16th, and the unit for frequency is always hertz. Okay guys, next one we're going to work is again on page 119, but it's number 32, and it says determine the energy in joules of a photon whose frequency is 3.55 times 10 to the 17th hertz. Now, first thing we have to do is write down is our givens. Now, it tells us that we have a frequency of 3.55 times 10 to the 17th hertz. And another given that we know, since we're finding energy, we know the equation for energy is going to be energy equals Planck's constant times the frequency. So we know what Planck's constant is, so we can go ahead and write that down, which is 6.626 times 10 to the negative 34th joules per second. Okay, so our unknown is obviously energy, and we just have to plug it into the equation. We'll have energy equals Planck's constant of 6.626 times 10 to the negative 34th joules per second, and we're multiplying that all by the frequency of 3.55 times 10 to the 17th hertz. Okay, and this will give us an energy of right around 2.35 times 10 to the negative 16th, and energy is always in joules. Okay guys, the next one we're going to be working is on page 120. It's number 44. And the problem says, what is the frequency of a radio wave with an energy of 1.55 times 10 to the negative 24th joules? Okay, so what we have to do is write down our given. First of all, we have our energy of 1.55 times 10 to the negative 24th joules. Okay, another thing that we know, anytime we're going to use energy, we are going to have Planck's constant, which is 6.626 times 10 to the negative 34th joules per second. Okay, and our unknown in this equation is going to be frequency. Now, to work out this problem, the equation we're going to be using is energy equals Planck's constant times frequency. So if we're solving for frequency, algebraically all we would do is divide both sides by Planck's constant, as we cancel, and we would get an equation that we're going to use of energy all divided by Planck's constant equals frequency. So we can go ahead and plug that in, and what we will get, we'll have frequency equals the energy of 1.55 times 10 to the negative 24th, and that is joules, all divided by the frequency, or Planck's constant, of 6.626 times 10 to the negative 34th joules per second. And we work that out, and we should get a frequency of 2.34 times 10 to the 9th. Remember, frequency is always in hertz.